Hello, my name is Zach Gibbs, and I'm a content developer within education services inside Juniper Networks. And today we will be going through the Paragon Active Assurance Multicast UDP Monitor Learning Byte. Alright, so here is the topology for our Learning Byte, and there are three main devices we want to talk about. We have TA1, TA2, and the control center. So TA1 and TA2 use ETH0 to connect to the management network, which then provides connectivity with the control center. And then TA1 and TA2 use ETH1 to connect into the service provider network. All right, so with that, what are we going to do? We need to configure a multicast UDP task. And so first, you probably know what multicast traffic is, but just in case you don't, multicast is normally used as a transport mechanism for services such as IPTV or even updating PCs at the same time. So by using the multicast UDP task, you're able to figure out how your network handles multicast traffic with things like end-to-end delay, jitter, and packet loss. And so this task, multicast UDP task, sends UDP multicast traffic from a server, which in our case is going to be TA1. And then TA2 acts as a client to receive the multicast traffic. And so what happens when the task starts? Well, first, TA1, which as we know is the server, generates multicast traffic towards the destination multicast address, which in our case is 239.1.1.100. Then TA2, which is the client, tries to join the multicast address. And if TA2 is successful at joining that multicast address, things like one-way delay, jitter, packet loss, and packet misorderings, that can be recorded. Now, one thing I do want to point out here is this would make a lot more sense if we had more than one client, because we are talking multicast. What is the point of multicast if we only have one client, right? Well, the concept still holds true with just one client. TA2 is our one client, TA1 is the server, and I don't have another test agent in the test bed right now, so that's why I'm using just one client. And so with that, it'll still prove the concept with only having one client. But typically you'd have multiple clients, at least two, probably 10, maybe 100 clients that would be subscribing to that multicast address. So just keep that in mind. Okay, so with that, what are some things we haven't talked about? Duration, we're going to set to 30 seconds. The server and the client we talked about. The rate we're going to set at 10 megabits per second. The multicast address of 239.1.1.100, we did talk about. The server port is going to be 3124. And then for error seconds threshold, we're just going to be using 0% loss. We could also say something about the jitter or the delay or whatever in the error second thresholds, but with this learning byte, we're going to keep it simple and put it at 0% loss for the only error second threshold metric. And then we'll run the monitor and examine the results. And so with that, let's go ahead and jump to the control center web interface and get this going. All right, so here is the control center web interface. Let's go to monitoring and then new monitor. And we'll name this Multicast UDP LB, LB short for Learning Byte. And then we'll select the Multicast UDP task. And you can see here that this is a puzzle piece task, which means we can add additional parallel tasks and we could run other tasks at the same time as this task. But for this Learning Byte, we are focusing on the Multicast UDP task. Okay, so with that, we need to fill out the general section. We need to specify the server, which is going to be TA1. We're going to be using the ETH1 interface for this. We want to make sure we select the right interface. If we were to select ETH0, that would be the management network, and we don't want to do that. Okay, so then the clients, this is just going to be TA2, the ETH1 interface. And then the rate, we're going to set that at 10 megabits per second. Multicast address, I'm going to say 239.1.1.100. And the port, recall that is 3124. And the loss is already defaulted to, for error second threshold that is already defaulted to 0%. Again, we could set the delay and the jitter for error second threshold, and also the expected DSCP. We could make sure that we're receiving expected DSCP value. But we're not going to worry about that right now. And so with that, let's go ahead and start the monitor. And we don't need to start this with a report. If you are running a monitor in a production environment, I highly recommend it. But for our Learning Byte, it's not necessary. And with any monitor, there's a bit of a setup time. It is a little longer than a test, so this just takes a little bit of extra time to get the setup going and whatnot. You can see here it's beginning to start, just be a few more seconds. Okay, you can see the monitor has started and things are looking good. We have complete green, no error second, so we are getting no loss. Because recall that we were only using the loss percentage for the error second threshold values. And so things are looking good. We got green across the board. light green across the board. I guess if it's dark green, we're getting a little bit of a loss, a little bit of error seconds, but that's not happening. So you can see things look good here, and we can click on the individual stream. Now, one thing I want to point out here, this might seem a little strange because it says TA1, ETH1, IPv4, then giving us an arrow to TA2, ETH1, IPv4. And that might seem a little strange because that almost sounds like it's unicast traffic, but it's not. What's happening is TA1 is sending traffic to that multicast address, and then TA2 is subscribing to that multicast address and receiving that traffic. And so with that, let's go ahead and click on the stream. We can look at some more information, and we can see here that we have some information in the graph. We can see here that we have the error second bar, the rate, and the average delay in milliseconds selected. And you can see here that at the top, we can see the rate, and which kind of makes sense. The average delay is so low that you can't really see anything. So let's go ahead and remove that rate. We know the rate is good. We're not getting any loss. So let's remove the rate from the graph. And okay, great. Now we're seeing the ES bar down here. There's no error seconds, so it's all green. That's great. And then we're seeing the average delay in milliseconds. You can actually see what's going on there. And that's pretty low. That's good. And then we could also select the max delay and the min delay. And you can actually see that showing up there. You can see how that's popping up here. You can see the max delay is kind of up higher there, but the average is pretty good. Well, let's deselect those. And then we can select the jitter as well to get some information on that. So you can see how the jitter is coming through. And then we can look at the table. The table will actually show us that information as well. Now, it doesn't show anything because there's no errors, so we need to use the show all command. And we're going to have to scroll down a bit to see it because remember, it takes a while to get it going. And so with the monitor, that is. So we do have to scroll down to start seeing the results. So you can see the results here. You can see the rate, the loss, misordered packets, none, delay, average delay, delay max, things like that. So you can see the individual statistics that are recorded for this monitor. And remember, since this is a monitor, it has a 10-second resolution. And so it's recording the statistics every 10 seconds. So this does bring us to the end of this Learning Byte. In this Learning Byte, we demonstrated how to configure and run a multicast UDP monitor. So as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Network's certification program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.